Hello. Okay, we're going to go straight to the next talk. So my name is Mark Greenslade. I'm working alongside Reto Trinkler at Trinkler Software, a little startup based down in Zug, Switzerland. And we're going to give two kind of talks. First of all, I will be talking, then Reto will be talking a little bit later. We're going to talk about a couple of products that we're trying to put together at the moment. The first of those products is called an Imagewallet. So we are trying to design a trustless multi-chain custodian solution that is scalable. I mean, scalable to a lot of people. The problem space we're trying to tackle here is that onboarding people outside the technological literati, if you like, is problematic. When you get into the numbers of millions, tens of millions, potentially hundreds of millions, it's not going to be easy to onboard people who are not conversant with the complexities of wallets, particularly in a multi-chain landscape. So, it's okay when you have one chain, but when you have N chains, where N may be quite large, and trying to manage wallets across all those chains is going to be a bit of a nightmare. And the kind of key to that is trying to reduce the cognitive overload of interacting with wallets to the minimal possible, but still retaining the strong security guarantees that you require. And lastly, and this is a little bit controversial maybe, is that whilst creating a wallet is an act of intent, giving out personal details is always an act of consent. And our wallet service needs to somehow tread a very fine line between these two poles, these two poles of behavior, intent and consent. So this really is the kind of problem space we're trying to tackle. And this is the three pillars, if you like, of our solution space. The first is image files. So images are mnemonics. They are very easy to remember. They are very personalized to yourself. They are very scalable. The whole world who have access to smartphones and such like are taking photos all the time. So images really do scale as a mnemonic, if you like. Deterministic keys, key derivation across multiple blockchains. This is, on the cryptographic side, the kind of manner in which we can simplify the experience. And then lastly, and this goes back to consent, is the kind of KYC requirements that decentralized applications may need in order to function. For example, an email address to send you notification of when something of significance has happened. That goes into that kind of KYC or consent land. So we are going to build, or plan to build, are building a service predicated on those three pillars. So if we look at the image file in a bit of detail, an image can obviously be a photo, or it could be a logo, personal to you or branded. It can be abstract. And as I said earlier, that really does act as your mnemonic. This is an example of an image wallet file for a product called Agora Trade that Reto will talk about a little bit later. Basically, it's pretty simple. We have a wallet generator that spits out from an HTML canvas object PNG file. It's password protected, and in this QR code we encrypt a random seed and some metadata. At the moment, this image wallet is developed as a node package, but we're going to move to Rust and WASM at some point in time, and the user experience to unlock is simply drag and drop and enter your password. So that is an example of a branded wallet. Here's an example of a personalized wallet. So the user is choosing an image, could be any image, and we overlay the QR code as unobtrusively as possible. In this case, we've put it down in the bottom right. The user can save that, maybe even print it. Opens up kind of nice use cases such as giving gifts, perhaps sending remittances, perhaps even direct aid. You know, can you imagine contexts where there may be a lot of social stress in a certain part of the world, and first world citizens who do have excess assets may wish to give direct aid to those folks. So that's the first pillar, image files. Second pillar is deterministic keys. So the derivation of essentially a master private key. This is all based upon BIP 32 proposal for hierarchical deterministic wallets. I'll go through the mathematics very quickly. We're taking a random seed, putting that through a pseudo-random generator to get a master private key. From that, we go through an elliptic curve to get a master public key. And then we go through a derivation sequence in order to forward project private and public keys across different chains. This derivation sequence has some properties that are useful for us. Is unordered, decoupled, and unlimited, so we can create as many of these keys as possible as we like. The derivation sequence is decoupled, so if we want I or I plus 2, we don't have to calculate I plus I to get to I plus 2 type of thing, and it's unordered. But obviously it's predicated upon safely storing that random seed, which within this kind of image wallet setup is in a QR code, which is protected by a password, so it is always going back to the password problem. Now, the custodian solution, or part of the equation. When a user wishes to interact with decentralized application services, a game begins to be played out. And this game, as I said earlier, is about intent and consent. On the intent side of the equation, creating a wallet in the first place, or exchanging coin A for coin B, or even lending coin A to people X, Y, or Z, you know, depending upon the decentralized application, could be a lending application. These are all acts of intent. But for those acts of intent to particularly on the last two here, there needs to be some form of consent that those services or applications can leverage in order to function correctly. They may require simply an email address, or they may need passport information, or your full set of KYC services, even usage histories. This is all stuff we don't like, but applications and services may require to function in the way that they are either designed to or they're obliged to, depending upon the regulatory context. So trying to square that circle is very tricky, actually, from a sociological perspective in particular. But our platform, hopefully, will support both acts of intent and consent via the custodial services that we will provide over time. Voila. So I'll give an extremely quick demo of where we're at the moment. Okay, I'll run a bunch of unit tests just for the techies in the crowd. So in these unit tests, we are doing stuff like mimicking client-server interactions, going through some of the cryptography stuff, checking hash functions, elliptical curves. Come through to the front end. So this is generating a wallet. Let's put a password in there. So that's the generation of a wallet. Just putting a QR code ready on an image. Save that to the file system. And then we can go into our decrypt function and pull that image up. And oops, put in the correct password. 1 second. always happens on a demo, doesn't it? Try one more. Oh, what am I doing? Okay, well, we'll move past the decryption phase. Always happens. Anyway, this is the front end of a larger application. That was just a demo that I used while I'm developing. And in this context, we're going to create a wallet. And we will select one of the pre-filtered, and this will create a wallet for us. Or we could, if I refresh that, we could import, add one from the file system. So let's go with that, which is okay, and that's added to the, and then we can create one based on there, and then we can save that. Get out of the way. Or we could save it. Try once more. As you can see, this is what you might call experimental. Okay, we'll just save that one. And then when we next come into the application, we can go and import that. Okay with that. And enter a password. I'm not going to go through this part because maybe there's a bit of an issue. But the point is that we have a workflow there where we're using an image wallet for to access our funds and to manage our funds. So over time, which this is a mock-up at the moment, we'll extend and support transactions across chains. So that was a demo. Like most demos, doesn't go exactly how you expect. That's the way it goes. But there's a problem anyway, and that's QR codes. They're really, really ugly, and they annoy me, and they annoy most users. So we've been looking at trying to solve that particular problem, and we've hit upon steganography. So steganography is effectively the art of concealing X in Y, proposed by a guy called Johannes Tritemius in 1499, actually a classic book that you might want to try and find out about, because it really is a classic in cryptographic history, and it tries to theory of stenography is subtly embedding bits within bits. So in this case, we have an original image and a recovered image. So the cat was actually embedded in the trees. So this kind of opens up the possibility of, within the original on the left, embedding our QR code in such a subtle way that the image on the left isn't affected at all. And obviously get back to our random seed. So we could, in theory, have image wallets that look like the users actually want them to look like. So that's Image Wallet. Now I'm going to pass over to Reto for his part of the talk.